Okay, in last class we saw the circuit model of the transmission line. We saw lossless transmission line, lossy transmission line, resonant transmission line. What will happen if we excite the transmission line by DC? What are the lossy element? Resistance and conductance, where the lossy element, they dissipate the energy in the form of heat, while your inductor and capacitor were the energy storage element, and that's why we say they are memory element. And at last moment we saw the classification of the line. In this lecture we will establish the equation for the transmission line. Whenever we establish the or develop the equation for the transmission line, we keep two things in our mind. The first thing is regime. Regimes where, what was the regimes? If the size of element is very less than the operating wavelength, then we use circuit theory, KCL and KVL. What will happen if size of element is comparable with operating wavelength? Then we use wave theory. If size of element is greater than the operating wavelength, then we use ray theory. This thing you must keep in your mind. Another thing, suppose that this is a conductor and its length is L and the total resistance is R. For L length the total resistance is R. For the unit length it will be R by L. For delta X length it will be R by L into delta X. So these two things you have to keep in mind. Okay, let's see. This is the transmission line, and I have considered only the unit cell of the transmission line. Recall that these elements are distributed along the length of the transmission line, and resistance and inductor they came in series form, and in capacitor and conductance were in parallel form. Recall that. Okay, I have assumed that this is delta X direction and your transmission line is guiding the energy in the delta X direction. Okay, I should say X direction. So why this, suppose that this is your Y direction, this is your X direction, this will be the Z direction. Then what will be the name of transverse plane? What will be the name of transverse plane? A plane which is perpendicular to the direction of propagation. So YZ plane will be the transverse plane. Okay, so I have considered only unit cell, and for this unit cell I have assumed that this delta X is, the length of this unit cell is very less than lambda. Then can I use the circuit theory? Answer is yes. Then what will be the value of resistance in the unit cell? Recall that earlier I explained the value of the value of resistance for the small section, it will be R into delta X. The value of resistance will be R into delta X, inductance L into delta X, C into delta X, G into delta X. Okay, so now at this end, look at here, the voltage is V, current is I. At this end the voltage is V plus delta V and current is I plus delta I. Why I have written I plus delta I or V plus delta V? Because there is change in voltage because of these two resistance, because they consume the energy. Change in current because of these two elements. Okay, so look at here, let's come in frequency domain. In frequency domain, L is written by j omega L and C is written by 1 over j omega C. In the circuit theory you have you studied. Okay, and according to Ohm's law we know that change in potential divided by resistance. In the frequency domain, all the elements, means resistor, inductor, capacitor, conductance, they behave like a resistor. Can we add these two resistance? Yes. Then what will be the value of these two elements? R plus j omega L into delta X. This like that. What? And always remember that current always flows from higher potential to lower potential. What will be the value of higher potential? That is V. What will be the value of lower potential? V plus delta V. So change in potential V minus delta V. This is nothing but change in potential. If we solve this equation, voltage divided by resistance will produce current. If I solve this equation, then I will get minus of delta V is equal to I times of this equation. Okay, let's modify this equation. Okay, then after modification of this equation, you can see this will become delta V over delta X minus I times of R plus j omega L. If delta X tends to 0, this operator will become dV by dx. In the mathematics, in the differentiation you studied already. Okay, let's we write the coupled equation or dual of this equation. What is the value? Dual of V is I. What is the dual of I? Dual of I is V. And what is the dual of resistance? That is conductance. What is the dual of inductance? Inductance, that is capacitance. Can I say equation B is nothing but it is the dual of equation A? Yes, we can say. Okay, let's try to understand. Current I is equal to V divided by R. Can I write current I is equal to V into 1 by R? Yes, we can write. Can we write current I is equal to V into G? Why do I say like G? Because 1 over R is producing G. Okay, so same kind of situation you are getting here. Current I is equal to V into conductance. Okay, so change in current should be given by this equation is equal to V into conductance G plus j omega C into delta X. Okay, if delta X approaches to 0, again you will get the same condition. If you able to produce this equation, then you can write this equation. When we solve the equation of transmission line, we always assume that all the elements are constant. Means all the elements matlab R, L, G, C are constant. And remember that this equation V depends on I, and this I depends on V. So that's why we say these two equations are coupled equations, है ना? So now one more thing. If I differentiate this equation A, then it will become d2V over dx square is equal to minus times of di by dx into R plus j omega L. Then you know the value of di by dx. Then put the value of di by dx. In next page I have done the same thing. Differentiate it and you get such kind of equation, and put the value of di by dx here, then minus will become plus, and you get such kind of equation. Then I write this equation like this: d2v over dx square is equal to gamma. This term is nothing but it's a gamma square, and gamma is nothing but it's a propagation constant. By looking this equation, this gamma equation of gamma square, you can say that your gamma is nothing but it's a complex quantity. As well as you can also say that your gamma depends on the primary constant of the transmission line. Okay, so let's modify this equation like this. And similarly you can write this equation. Write the dual of this equation. Voltage should be replaced by current, the current, and these two equations are saying something to you. Means these two equations are nothing but they are the wave equations. Means they are saying that these two equations are saying that in the transmission line, voltage and current, they travel in the form of wave. Okay, they are also saying that voltage and current are propagating in x direction along the length of the structure. Okay, and they also say whenever the current and voltage wave travels in the transmission line, they suffer attenuation. Why do I show attenuation? Gamma is nothing but propagation constant, and propagation constant is nothing but alpha plus j beta, and alpha is nothing but it is attenuation factor, and beta is known as phase constant. Okay, so if there is attenuation, means that your energy of the wave will be attenuated along the length. Okay, so these two equations are saying that your voltage and current travels in the form of wave. Okay, in next lecture we will see the solution of these two equations, and this is all about for the today's lecture. And this is the transmission line equation, sometimes we say telegraphers equation. So it's very simple to develop these two equations, you have to keep in your mind. And always remember, your gamma is propagation constant, it is a complex quantity which depends on the primary constant of the transmission line, and gamma is nothing but it is alpha plus j beta. Alpha is representing the attenuation. If suppose that if alpha is 0, then will wave attenuate in the transmission line? Answer is no. Okay, what will happen if beta is 0? This is the question for you, this is the assignment for you. What will happen is if beta is equal to 0, wave will only what will happen? Just you find the answer. Okay, so thank you very much, and please watch my next lecture.